in this question, ammonia is produced by the Haber's process. The equation is shown. Nitrogen reacts with 3 hydrogen as usual to form 2NH3. These all are gases, and the reaction is exothermic. So when he says that the reaction is exothermic, even if he doesn't say, we know that he means the forward is exothermic, and if the forward is exothermic, so the backward is going to be endothermic reaction. Anyway, this is the question. Which statement is correct in this? Which statement is correct? A. Increasing the pressure decreases the yield of ammonia. If I increase the pressure, the system will try to do what? It will try to decrease the temp. Oh, he's talking about the pressure, not temperature. So increasing the pressure will decrease the pressure. So it will move to the direction of less moles, which is forward. So more ammonia is formed. More ammonia is formed. So the yield of ammonia increases, not decreases. So this is wrong. Increasing the temperature, the system will try to decrease the temperature, so it will move to the endothermic. Endothermic means backward, so nitrogen and hydrogen increases and ammonia yield decreases. So decreases the yield of the ammonia, but speeds up the reaction. Yes, that's correct, because when you decrease the temperature, you increase the rate of the reaction. So that's correct. You go to the left, but you increase the rate of the reaction, which is correct. Increasing the concentration of hydrogen and nitrogen, the system will try to decrease them. So it will move where? If you increase the concentration of hydrogen and nitrogen, it will try to decrease them. So it will move to the ammonia. It will not try to make them. It will move to the ammonia. So it increases the yield, not lowers the yield of ammonia. Increasing the temperature will decrease the temperature. So the system will try to move to the endothermic, which is backward. So decreases the yield of the ammonia, not increasing it. So that's wrong. So the only one is that when you increase the temperature, the system tries to decrease the temperature, so it moves to the endothermic, and this decreases the yield, meaning yes, it's correct, it decreases the yield, but it increases the rate of the reaction. Take care, there is two different things. There is two different things. You have to be very sure about this one. Talking about the rate of the reaction and talking about the yield and the equilibrium. When you see the effect of temperature on the rate of the reaction, it increases the rate of the reaction. But which one, the forward or the backward? This depends on the equilibrium, if it is endothermic or exothermic. But when we talk about the rate of the reaction, we know that increasing the temperature, increasing the rate, here it does not specify in which direction. And when you decrease the temperature, you decrease the yield. When I'm thinking and the production of ammonia, there are two things: thinking about the yield and thinking about the rate. The yield is that I make more ammonia. This is important for me. And also more important is that the reaction rate is fast. So which one is more important to me? In the explanation, we have agreed that the rate is much more important than the yield. I don't care if I get more ammonia, but very slowly. If I am making ammonia and I have a plant or a factory to make ammonia, which one is more important to me business-wise? To make more ammonia or to be faster? If I make a lot of ammonia, but in very slow process, it takes months, I don't care about this. But if I make less yield, so less yield and faster rate is much better. Faster rate is much better than more yield and slower rate. Take care, and slower rate. This is very important to understand. Less yield and faster rate is much more better than more yield and slower rate. So here I said I am increasing the temperature, which decreases the yield because I formed less ammonia because I moved backward here, but I speed up the reaction. I make the reaction faster because I have increased the temperature. So this means that I have decreased the yield, but I have increased the rate of the reaction, which is very good for me. This is actually the best option to do in this Haber's process.